In this video, we have an exponential equation to solve. How do we get this kind of exponential equation done? Let's see what to do to make sure that we obtain the value or values for our x. We have 6 raised to the power of x plus 9 raised to the power of x equal to 2 raised to the power of 2x plus 1. When you have this kind of question in your hands, the first thing you want to do is to break this thing down. Here is 6 raised to the power of x plus 9 raised to the power of x equal to 2 raised to the power of x multiplied by 2 raised to the power of 1. How did I get this? This is one of the laws of indices. One of the laws of indices says if you have a raised to the power of m multiplied by a raised to the power of n, and then you are going to have a raised to the power of m plus n. You simply add the powers together in as much as they have the same base. So it's like we are reversing 2 raised to the power of 2x plus 1 back to its original form. So they must have gotten the same base before the powers can be added. So if we follow this law, you observe that it's going to be 2 raised to the power of 2x plus 1. So we are reversing it back to 2 raised to the power of 2x and then multiply by 2 raised to the power of 1. And then we need to express it this way: 6 raised to the power of x plus 9 raised to the power of x equal to, and then the interpretation of this, it means 2 raised to the power 2 multiplied by x this way times 2. And then we just want to write 6 raised to the power x plus 9 raised to the power of x equal to 2 squared here is 4 raised to the power of x, then multiply by 2. And then let's divide all through by 4 raised to the power of x. So if you divide all the terms you have there by 4 raised to the power of x, so we have 6 raised to the power x divided by 4 raised to the power x plus 9 raised to the power of x divided by 4 raised to the power of x equal to 4 raised to the power of x times 2 divided by 4 raised to the power x. And then we can actually divide or cross that one out. And then this and this, you discover that they carry the same power. Therefore, it can be expressed as 6 over 4 raised to the power of x this way. And then plus this one too can be expressed as 9 over 4 all raised to the power of x, in as much as they carry the same power. And then we're left with just 2 here. And then how do we express 6? 6 can be expressed as 3 times 2, or 2 times 3, everything over 2 times 2 all to the power of x. And then plus this one too, the 9 can be broken down to 3 times 3, and 4 itself can be 2 times 2 all to the power of x, and then equal to 2. And then this can get rid of this, so we're left with 3 over 2 raised to the power of x in this way, okay, plus, and this one too can be 3 squared over 2 times 2 can be 2 squared, all still raised to the power of x equal to 2. And then therefore we have 3 over 2 raised to the power of x, okay, plus, in as much as both 3 and 2 here carry square, so we can just write it as 3 over 2 square. And then since we have x as the power, then multiply by x equal to 2. Don't forget this is x there. And therefore our 3 over 2 raised to the power of x plus this one can just be written as 3 over 2 raised to the power of 2x equal to 2. So in this case, we need to make use of what? Of a letter to represent 3 over 2 raised to the power of x. So let's say we say let letter p, okay, represent, okay, let letter p represent or be equal to 3 over 2 raised to the power of x. Okay, what that one means is that wherever we say 3 over 2 raised to the power x, we're going to substitute that with respect to letter p. Okay, so in this case we're having just p, that's 3 over 2 raised to the power x, plus, don't forget this one means 3 over 2 squared times x. So there is 3 over 2 raised to the power x then square, so it becomes p squared equal to 2. And then this is looking like factorization, or this looks like a quadratic equation rather that we can easily factorize, and therefore we can just rewrite this one as p squared and then plus p equal to 2. So we can just move this to the other side of equality sign, that becomes p squared, okay, plus p, and then moving this to the other side of equality sign, that becomes minus 2. And then in order to take it, okay, sorry, we have equal to 0. Nothing is left in the other side of equality sign there. So in order to actually get the value for p, we can easily factorize. And if you discover that you don't want to use factorization method, there are other methods you can use to get a quadratic equation done. We have using the quadratic formula. We can also use completing the square method, but this can easily be factorized too. We can just go ahead and factorize a quadratic equation there. And then this becomes, don't forget, this is p squared, and then plus p minus 2 equal to 0. If you are still struggling with factorization method, I refer you back to one of my videos on factorizing on quadratic equation. You can just go and watch and gain some kind of fundamental understanding on how to factorize quadratic equation there. So here we have p squared plus p minus 2 equal to 0. So we can just multiply this and this together. This becomes minus 2p squared. So two factors to be multiplied to get minus 2 and to be added to get plus 1, because 1 is the coefficient of p here. And that gives us p squared plus 2p and then minus 1p, which is minus p, and then minus the constant itself equal to 0. And then we can pair this one up, and then we can pair this one up this way. Okay, what is a common term between p squared and 2p? Of course, that's p in the bracket p plus 2. And then minus a common term between p and minus 2 is 1. 1 is a common factor to every terms, be it letter or be it a number. Therefore, this one, p divided by 1 is p, minus times minus there is plus, 2 divided by 1 is 2, equal to 0. And then we'll pick one of the terms of the bracket and combine this and this together. So p minus 1 in the bracket p plus 2 equal to 0. So each of the term is expressed to be equal to 0 so that we can obtain the values for our p. So we have p minus 1 equal to 0 or p plus 2 equal to 0. So moving the constant term to the other side of equality sign. So we have p equal to 1 or p equal to minus 2. But what we have to solve is not for p. The question originally is in terms of x. So solving that question is to obtain the values for x. So we've got to recall that don't forget we said 3 over 2 raised to the power x. We represented it with p. So we have to recall that our 3 over 2 raised to the power of x equal to p. So if we equate these two, now that we've gotten values for p, we can easily get values for x. So we pick it one after the other. So the first one we want to do is when p equal to 1. And don't forget we said 3 over 2 raised to the power of x equal to p. And then this one is going to be 3 over 2 raised to the power of x equal to 1. And then we can just write it out as 3 over 2 raised to the power of x equal to 3 over 2 raised to the power 0. One of the laws of indices says whatever is raised to the power of 0 equal to 1. So we can just represent this as 3 over 2 raised to the power 0 so that they have common base. And then once you have an indices this way, we can just equate the indices. So we write equating the indices. So if you equate the indices there, you discover that your x is going to be equal to 0 because 3 over 2 is equal to 3 over 2. Therefore, the powers 2 will be what? Equal to one another. So we've obtained the values of x equal to 0. So let's check for the other value of p. The other value of p is when p equal to minus 2. So when p is equal to minus 2, okay, let's obtain values for x. Don't forget we have 3 over 2 raised to the power x equal to p. And then in this case, we have 3 over 2 raised to the power of x equal to p is minus 2. In as much as your answer is a negative value for p. And then the solution here is no solution. You can obtain any number that will be raised to the power of 3 over 2 that's going to get minus 2. So there is no solution here. So it's impossible. And therefore, our answer to the value of x in that exponential equation is x equal to 0. And you can just check. If you want to check if what you have obtained is actually correct or not, you can bring in the question itself. Let me just write it out this way. This is like a check. Okay. Remember we said 6 raised to the power of x, okay, plus 9 raised to the power of x is equal to 2 raised to the power of 2x plus 1. Let's check. if 0 is actually the correct answer. Don't forget, anything raised to the power of 0 is 1. So here it means 6 raised to the power of 0, which is going to be 1, plus 9 raised to the power of 0, which is going to be 1, equal to, here it means 2 times 0, which is 0. So we have 0 plus 1 is going to give us 2 raised to the power 1. So here is 2 raised to the power 1. So what is 1 plus 1? That's going to be 2. And here we obtain 2. So that shows that x is indeed equal to 0. That's how to solve such exponential equations. Kindly subscribe to my YouTube channel.